Okay, really quick video on correlation and causation and the idea that correlation does not imply causation, okay? That correlation and causation are not the same thing, okay? So even if you were to draw a scatter plot, work out your correlation coefficient and get a correlation coefficient of 1 or -1, so kind of perfect correlation, really, really strong correlation, it still doesn't prove one of your variables causes the other. Okay, so really strong correlation does not prove that one variable causes the other. Okay, so just don't go too far when you're drawing conclusions in your assignment, and then in the next couple of years when you do statistics at Leaving Cert, don't go too far in drawing conclusions when you're answering questions and stuff like this. So don't, just be careful with that word cause. Okay, so what could be going on apart from one causing the other? Why might two things be really, really closely correlated without one causing the other? Well, it could be a result of coincidence, or it could be what we call a lurking variable. I'll look at a couple of examples of those in a second. It could also be the direction of causality. If you think one thing causes the other, it could actually be the other way around. If you think X causes Y, it could be Y causes X. Um, so basically, further research or study is always required in the questions that you'll do and in the assignment that you'll do. Okay, you won't be doing enough to prove a causal relationship. So here is a scatter plot of the total US highway fatality rate versus fresh lemons imported to the US from Mexico in metric tons, okay, over a 5-year period. Okay, we can see these points come very close to forming a straight line. This scatter plot gives us R squared of 0.97. That's closely related to the coefficient we've done. I think that would give you a correlation coefficient, the R that we've done, of minus 0.98. So very, very strong negative correlation. Okay, does that mean importing more lemons causes the highway fatality rate to go down? Should the US government import more and more and more lemons to make that fatality rate go down? No, of course they don't. Okay, these two things just happen to be correlated by coincidence. All right. Next one. I've got a scatter plot of the Nobel laureates per 10 million of population and chocolate consumption in kilograms per year per person for a lot of countries. Okay, now Nobel laureates just means number of Nobel prizes that these countries win in the different sciences, in economics, in literature. Just again, note it's per 10 million of population and it's per capita per person. So these are all adjusted for population. Okay, so it's not just bigger countries obviously winning more or consuming more. It is adjusted for the size of the countries. Okay, you see a positive correlation here. There is a pretty decent kind of straight line you could draw through those, and it's giving me an OR of 0.791, so strong positive correlation there. Okay, so does that mean the more chocolate you consume, the more Nobel prizes you win? Should the Irish government be buying lots of chocolate and sending it out to schools to ensure we win more Nobel prizes? No. What's actually going on here? It could be coincidence, I don't know, but I think what's going on here is the lurking variable of how rich the countries are. So basically how rich the countries are causes both of these to go up. So we call that a lurking variable. It's causing both our variables to increase. So the richer a country is, chocolate's a luxury product, so the more chocolate the countries consume. And the richer countries are, the more Nobel prizes they win. Okay, Nobel prizes are, most of them are in the sciences, so you'd need a lot of money to set up the kind of scientific labs and facilities to win them, or have like kind of world-class universities, which might help you win them. Okay, so it's wealth, how rich the countries are, a lurking variable causing both. Next one I will look at is ice cream sales versus shark attacks, and we see that they're quite grossly correlated over a number of years. The more ice cream that's sold, the more shark attacks there are. Okay, so does this mean causing eating ice cream causes you to be more likely to be attacked by a shark? Is this what's going on? Eating ice cream causes you to taste better, means you're more attractive to a shark? No. Okay, what's going on there? It's the warm weather or hot weather or temperature, however you want to say it, is causing both. Okay, so the hotter the weather, higher ice cream sales. The hotter the weather, more people are in the water, more shark attacks happen. Okay, so hot weather or good weather there is a lurking variable which is causing both to increase. Okay, so there's a couple there with lurking variables. One I've seen with a coincidence. This website here, Tyler Vigen, he has basically programmed something to go through data sets all around the lots and lots of data sets which he's found on the internet and try and find correlations amongst them. Okay, so you can kind of see these kind of silly correlations which are just there by coincidence. So, for example, the number of people who drowned by falling into a pool and the number of films Nicolas Cage appeared in are quite closely correlated. In the 10 years from 1999 to 2009, the coefficient there is 0.66, so strong positive correlation. It's shown there in a trend graph rather than a scatter plot, but if you put that in a scatter plot, it'd be quite close to a straight line. There's no reason both of those go up and down together. Okay, it's just coincidence. Next one, per capita cheese consumption correlates with the number of people who died by becoming tangled in their bed sheets. Correlation coefficient of almost 0.95 there. Okay, so those two things are very closely correlated. Is one causing the other? No, it's coincidence. Okay, so again, just be very careful around saying one variable causes the other, even if you have very, very strong correlation.